Hello, my dear students. So today we are going to discuss about the very important effects involved in the reaction mechanism of organic compounds. If we will understand these effects, then it will make us very easy to understand the reaction mechanisms involved in the organic chemistry. So we are going to discuss about the 5 effects that influence the reaction, that influence the reactivity of organic compounds. The 5 effects are: the first one, inductive effect; second, electromeric effect; third one is mesomeric effect; fourth is hyperconjugation; and the fifth one is resonance. So let us start with the first one, that is inductive effect. So what is this inductive effect? Inductive effect. If we talk about the organic compound, then there are two types of bond, basically sigma bond and pi bond. In case of sigma bond, suppose there is a sigma bond between carbon and a halogen, let it be X. Among these two, here they share a pair of electrons to form sigma bond. Sigma bond is there. Now, in this sigma bond, there is an electron pair. If we see these two atoms, then one of the atom is electronegative. Electronegative than the other. Now, this electronegative atom is electron loving group. Since it is electron loving group, the electron pair which is found in the sigma bond shift slightly towards the electronegative atom. Due to this shift, what happens here? In this X atom or in this halogen atom, a slight negative charge develops. At the same time, what happens? As the electron move away from this carbon atom, it develops slight positive charge. This kind of development of positive and negative charge due to the shift in sigma, that sigma electron towards the electronegative atom, is called inductive effect. And this inductive effect, it can be represented as plus I effect and minus I effect. The electron withdrawing group, electron loving group, they show minus I effect, whereas electron releasing group show plus I effect or positive inductive effect. Here carbon is electron releasing group, so it has plus I effect, whereas this X atom or halogen atom or any other electronegative element, it has the capability to accept electron, to withdraw electron, so it shows minus I effect. And this kind of polarization is permanent. So this inductive effect is a permanent effect. So we can define it as the shift of sigma electrons towards the electronegative atom in a sigma bond, which causes permanent polarization, is called inductive effect. This inductive effect, it may occur in saturated as well as unsaturated hydrocarbons, but it occur only in sigma bond, not in pi bond. And this effect, as it occur in sigma bond, sigma bond is a stronger bond, If the bond is stronger, then the effect will be weaker. So sigma bond is stronger, but the effect is weaker. Now, if we talk about the second effect, that is electromeric effect. Electromeric effect. This electromeric effect is a kind of temporary effect mainly found in pi bonds, not in sigma bond. Here, it is also a kind of polarization, but due to the shift of pi electrons towards one of the atom in unsaturated hydrocarbons. Suppose there is an unsaturated hydrocarbon having double bond between the carbon atom. Here one of the bond is pi bond. Now if the pi electrons shift towards the one of the carbon, suppose the electrons shift towards this carbon and it changes like this, due to which it develops the negative charge and it develops positive charge. Then this kind of effect is called electromeric effect. This effect is a temporary effect, as I have mentioned here, because it occurs only when the reagent come in contact. But when the reagent is removed, then again it comes in its original ground state. When the reagent removed without allowing the reaction, then what happens? Again it comes in its original state. So this effect is seen only in pi bonds, not in the sigma bonds, and it is seen only in case of unsaturated hydrocarbons, not in case of saturated hydrocarbons. Since we find pi bonds in case of unsaturated hydrocarbons, this electromeric effect is seen in unsaturated hydrocarbon only. Now we know that pi bond is weaker bond. So this effect, electromeric effect, will be stronger. Weaker the bond, stronger the effect. Stronger the bond, weaker the effect. So inductive effect is weaker effect, but electromeric effect is stronger effect. Now, how can we define the electromeric effect? It is a temporary polarization that occur in unsaturated hydrocarbons due to the shift of pi electrons. When the reagent is brought nearer to the unsaturated hydrocarbon. But if the reagent is removed without allowing the reaction, immediately it comes to its original ground state. So that is why we call this electromeric effect as a temporary effect. Okay. So the next effect is mesomeric effect. We will discuss about that, hyperconjugation and resonance. We will discuss in the next video. For today, only this much. Thank you very much.